Hey everybody, this is the notes for section 3.4. This is the second to last section in this chapter. So in this section, we're going to talk about the slope-intercept form of a linear equation. There's two forms, and this is probably the one, if you're familiar with either, this is the one you're familiar with. It is in the format y equals mx plus b. M is always the slope, and b is the y-intercept. It's part of the point 0, b. It is a format that makes it easier to graph equations because we know the slope, the rise over the run, and we also know where it intersects the y-axis. So if we look at each of these equations, what's the slope and the y-intercept? So for the first one, m is always the letter we use for slope. The y-intercept is, for the first one, whatever is with x is the slope, so it's 3 over 1. And the y-intercept is going to be -1, so it's at 0, -1. For the second one, it's -2.7 over 1, and then 0, 5. And then for the last one, it's 4 over 1, and then there's nothing there, right? So like, if there's nothing on the end, does that mean there's no y-intercept? Well, no, actually it doesn't. Because technically what we could do is add on a 0 to the end, and that makes the y-intercept 0. So the equation, what you know is that line goes directly through the origin. Given something like this, what we do most often is we take an equation and we reformat it into slope-intercept form. So what we have to do to start is put it in that y equals mx plus b format. And we do that by simply using the tools we already have to move things around. So I have -5 minus 2y plus 6. I'm going to add 5x to both sides. Pardon me. Minus 2y equals 5x plus 6. So I'm partway there. And then I'm going to divide everything by -2. That's the last step. And then I can split that. So I'm going to go this way. So I get y equals 5 over -2x plus 6 divided by -2 is -3. So I'll rewrite that so it doesn't look so crazy. Equals -5 over 2x minus 3. That's it. That's what we're doing here. The slope, we know, is going to be -5 over 2. The y-intercept is going to be 0, -3. That's how this works. Let's try another one. So pause for a moment and try it. See if you can do it yourself. Do the transforming of the equation and then identify the slope and the y-intercept. So it's 2x minus 6y equals -3. Move the 2x to the other side. Subtraction. I get -6y equals -2x minus 3, and divide everything by -6. In this case, we're just going to simplify the fractions. So I'm going to get negative and negative is positive, so 2 over 6 is the same as 1/3 x. -3 over -6 is the same as half, so plus half. That means that the slope is 1/3, 1 over 3, and the y-intercept is 0, half. That's all there is. All right. So now what we can do is we can graph equations based on this, based on what we know about the slope and the y-intercept. So if we look at this equation, we know the slope is -5 over 2, means it's going down 2 and right, or sorry, down 5 and right 2. The negative either applies to the top or the bottom. So it's either thinking about it as -5 over 2, or you're thinking about it as 5 over -2. My tendency is to put it in the top of the equation just so I don't lose track of it. And then the y-intercept is going to be 0, -3. All right, so 1, 2, 3. We're going to start with the y-intercept, and then we're just going to count. 1, 2, 3, 4, 5 down, 2 to the right. And since I'm going to run out of space, I'm actually going to go the opposite direction from my original point. I go 1, 2, 3, 4, 5 up, and 2 to the left. And that should make a line. Lines get arrows on the end because technically they continue forever, right? All right, you try this one. So pause for a second. write down the slope and the intercept, and then graph it. So in this case, the slope is 2, so 2 over 1. Everything's positive, so it's going to go up and to the right. And the y-intercept is 0, negative 3, same one as last time. So I'm going to put the y-intercept on the graph first, and then I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Remember, we always want at least 3 points so that we make sure we're going in the right direction. And there is my line. All right, let's try another. This one is slightly different, only because it's y equals 4x. But like we saw before, when we have that 4x and nothing else, technically we're adding 0. So here the slope is 4 over 1, up and to the right, and the y-intercept is just at the origin. So I'm going to put that in first, and from there I'm going to go 1, 2, 3, 4 up, 1, 2, 3, 4 right. And since I'm going to run out of room, I can do the opposite. So instead of going up and right, I can go down and left. And there's my, very not straight line. All right, do one more. This one's slightly different, right? So in this case, just like before, I have that 0. The slope is negative 1 over 4. So it's going to be down 1, right 4, or up 1, left 4. And then the y-intercept is at 0, 0, just like before. So y-intercept is the origin. Then I'm going to go down 1, right 4, or up 1, left 4. And there is my line. All right, not terrible. So in this, what we can do is look. Remember in the last lesson we learned about parallel or perpendicular or neither. For each pair, we want to know if they're parallel, they're perpendicular, or either. Remember, when they're parallel, their slopes are equal. When they're perpendicular, the slopes are negative reciprocals of each other. And if it's not either of those things, it's neither. The puppy has decided to participate in our call. Pardon me. Hi, Lou. We have a young puppy right this second who has decided she wants to be a part of our conversation. All right, so if you look at the slopes of each of these, that's all I'm looking at. The rest does not matter. So in this first 2 pair of lines, the slopes are both 3. Luna, I can't help you right now. You gotta go if you're gonna bark. Here, here. All right, pardon me. So they're both 3, they're both exactly the same. That's gonna make them parallel. For the second pair, again, all I'm looking at the slope 3 over 2, 2 over 3. Those are reciprocals, but they are not opposite signs. So they are neither. And if we look at this third set, let's see, they are not reciprocals, but they're opposite signs. So they are also neither, which is apparently a word I can't spell today. And then in this last set over here, 5, 6, and 5, 6, these guys are parallel because they're exactly the same. Sometimes we have to do some work to get to that point. Remember that we need both equations to be in y equals mx plus b format before we even look. Please don't try to guess your way to it. Don't just look at what's with x, because as you move stuff around the equation, things change. So let's reformat them. This one is x minus 3y equals negative 5. I'm going to move the x to the right. I'm going to get negative 3y equals negative x minus 5. I'm going to divide by negative 3. And I'm going to get y equals 1/3 x plus 5 over 3. And then for the second one, the dog is participating, pardon me. For the second one, I'm just going to move, I'm going to add the y to the left. I'm going to get y plus 3x equals 4, and I'm going to subtract the 3x. So I'm going to get y equals negative 3x plus 4. So if I look at the slopes, one of them is one of them is 1/3, the other is -3. Those are negative reciprocals. So these guys are perpendicular. But we had to do some work to see that. And if you just took it at first glance, you wouldn't have noticed. This one, x equals 2. I don't know what's happening there. And y equals 8. So if I divide the y equals 8 both sides by 2, what I see is it's really y equals 4. So what I have here is x equals 2. That is, all the y values are equal to 2 no matter what all the x values are equal to 2 no matter what y is. So that is, oh, and something is updating. Good Lord, my computer. That is all kinds of things going on. One of these lines is horizontal. The other's vertical. That means these guys are also perpendicular. Okay. Do the same here. What you're going to see in the second example is these guys are perpendicular. And in the top one, when you figure it out, these guys are also perpendicular, but you need to do the work. So do the work and see if when you try it out, you can figure it out. If you can't, bring it to the discussion. That's why we're here. All right, sometimes what you get is the slope and the y-intercept, and you have to figure out what else to do. So if the slope is 2/3 and the y-intercept is 0,8, we need to write that into equation form. So all I'm going to do is think about my y equals mx plus b. I know I'm going to keep y. I know m is 2/3. X stays and b is 8. That's it. You try the next one. What goes where? So I get, it should be y equals -4x minus 10. All right, 2 more quick examples here. So write equation of a line, pardon me, having a slope of 2 and passing through the point -3x plus 1. In this case, I don't have the y-intercept, so my job is to find it. Based on the information I have, I can do that. All right, we took a little puppy break there for a second. My apologies. This video is going to take forever. So if it has a slope of 2 and it goes through -3, 1, I'm going to put -3, 1 on my graph, -3 down, sorry, left, up 1. And then I'm going to go up 2 over 1, or down 2 over 1. So what you're going to see is it goes through the graph right there between, let's see, where am I? 1, 2, 3, at about, what, 3.5? Okay, so when I write my equation, it's going to be y equals 2x plus 3.5, give or take. Okay, you try the next one. So it has a slope of -3, and it goes through the point -2, -5. Oh my goodness, Luna Bell. See what it looks like. I'm going to graph. You're going to try it. I'm going to tell you the equation. The equation turns out to be y equals -3x, because that's the slope, minus 11. That's where the y-intercept is. So try it. And then if you have questions, bring it into the chat, or the discussion, pardon me. Remember, do whatever it is next in the module from here. Might be the next video, might be moving on to work. If you have questions, reach out.